Yeah. Are you able to see this?
Yes, ma'am.
Yes, ma'am.
Okay. So now this is a new paper where I have drawn the final magnitude plot that we had. In the previous sheet, what I had done is I have sketched a reference plot and then I had shifted it upwards by 20 dB to get the final plot. Here, this is the final plot. So here you can see that at omega equal to 1, we have magnitude as 20 dB and the whole graph is shifted upwards. Okay. Now, what we are supposed to do here, we are supposed to find the gain margin and phase margin. Before that, we need to identify omega GC and omega PC. Okay. Now, for omega GC and omega PC, we need to remember the definitions of both. Gain margin and phase margins are calculated from omega GC and omega PC, and omega PC is phase crossover frequency, where the frequency at which the phase plot crosses minus 180 degrees. Okay. Now, in this case, at this point, the phase plot crosses minus 180 degrees. Okay. So we have marked this point and name it as omega PC. Similarly, what is omega GC? Omega GC is gain crossover frequency. So the frequency at which the magnitude plot or gain plot crosses 0 dB. So this is the 0 dB line and this is the point at which it crosses 0 dB. So this is frequency which is called as omega GC or gain crossover frequency. Now let us come to the calculation of gain margin and phase margin from the plot. So what we are supposed to do is gain margin is calculated from omega PC and phase margin is calculated from omega GC. How? Now omega PC point we have, just take it upwards, draw a dotted line till it intersects with your gain plot. Okay, at this point it intersects. So this much is the gain margin, this much is the margin that can be added to the system till the system becomes unstable. So this much is the gain margin, which I have calculated from the graph as around 21 dB. This has to be precise, but when you have semi-log paper, it will be better for the calculation. Okay. Similarly, phase margin is calculated from omega GC. Now mark omega GC and draw a dotted line till it crosses phase plot at this point. Okay. And this much amount of phase can be added till the system becomes unstable. Okay. So this value is known as phase margin. In phase, you can calculate it. I have calculated it around 33 degrees. So gain margin is 21 dB. Phase margin is 33 degrees. Both are positive, and so the system is said to be stable. Now you might have question, how can we say that both are positive? Now just take a look at this one. Okay, let me just erase. Okay. Now here this point, what is this point? Say minus 21 dB at this scale. Okay. From minus 21 dB, you are supposed to go to 0 dB. So how much do you need to add? Plus 21 dB, right? So for that, this plus 21 dB is considered to be the gain margin and it is considered positive. The calculation for phase margin is little bit different. All the angles that we are marking are negative angles, right? And this negative sign does not indicate that the angle is negative, but it indicates the direction of the angle. And if all the angles are negative, that means the angles are getting added in the same direction, right? So in this case, you might ignore this negative sign for checking whether the phase margin is positive or negative, and then you can see here, this is around what is it, the value 133 or something, or 134, 135, and then you can calculate it up to 180. You are at 135, for example, and you are going towards 180, ignoring the sign. I hope you have understood why are we ignoring the sign, because all the angles are negative. We are keeping, or we are getting the angles added in the same direction, not in opposite direction. If it would have been in opposite direction, then that would have been considered as negative. But here we are adding it in the same direction, so we are having positive phase margin. So that is why phase margin and gain margin both are positive, and then the system is said to be stable. Okay, so this is how it is done. Let me just revise again what we did. We have this magnitude plot, we have phase plot. From phase plot, you identify omega PC, that is phase crossover frequency, the point at which it crosses, phase plot crosses minus 180 degrees. You identify omega GC in the gain plot when it crosses 0 dB. Then take the lines upwards, draw dotted lines till it intersects gain plot. Same happens with omega GC. Take this line down and draw it till it crosses phase plot, and then this would be the actual, on the scale you need to calculate what is gain margin, and from this phase margin. So please remember that gain margin is calculated from omega PC and phase margin is calculated from omega GC. When both are positive, the system is stable. It might happen in some problems that phase margin is infinity, or phase margin is 90 degrees, gain margin is infinity. It might be anything. As long as it is positive, the system is said to be stable. Okay. Now please let me know whether you have understood it or not.
Yes, ma'am.
All of you?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So now what I'll do is I'll just share a screen with you, which I have obtained using MATLAB. In MATLAB, you just need to give two commands by providing the actual transfer function. It will return the Bode plot to you. Only thing is that this Bode plot, the magnitude plot and phase plot, please understand this magnitude plot is not asymptotic in case of MATLAB. When we have semilog paper, we must draw asymptotic plot. This in the MATLAB, we do not get asymptotic plot, but still we get the shape of the magnitude plot. Okay. Now there are few things to notice, so I'll just mention them. Magnitude in dB. Okay. So this is 0 dB line. Here we have minus 180 degrees. In this particular case, in this particular problem, what I had shown to you was the random phase plot. I had not plotted it as per the calculations in the phase plot. In this particular problem, as you can see, the phase plot is not crossing minus 180 degrees. It is just going along minus 180 degrees. It is not crossing. That means you're not going to get omega PC. Okay. Or omega PC can be considered to be at infinity. In that case, you will get, now at infinity, suppose you get omega PC. In that case, you will get phase margin equal to infinity, plus infinity, because gain plot has already crossed this line. Now this point is nothing but omega GC. You can take this down, and then this much would be the phase margin. Okay. So in this particular problem, we can see this. Now, most importantly, you can see on this scale, we have a semilog paper in the background, semilog grid, you can see. So this is how the semilog paper looks. You can see the frequencies 10 raised to minus 1, that is 0.1, then 10 raised to 0 is 1, then 10, 100, 1000, and so on. And these are the spannings of a decade. So each one of these are known as decade. And what I was telling is, you mark the point, say 20, 40, and say 60. For example, I'm showing this will be slope per decade. That will be the reference line that you will draw. Okay. And then you will draw the lines parallel to these lines for sketching the appropriate plots, appropriate slopes. Okay. So this is how the Bode plot works. Now, one last point I would like to mention here. Now, what we have is, in your actually, I mean, this part was this topic is part of 4th unit, and you were supposed to solve online exams, I mean MCQs also on this. So in the online exams, they used to give the questions exactly other way around. Like, you will be getting the gain plot, and then from gain plot you are supposed to guess what the transfer function is. So that is one type of problems that we can have. If you all are interested, I can show it right now, or you just practice actual plotting of Bode plot and sketching the Bode plot, and then later on I can show 1 or 2 problems which are given in your notes. Actually, if even if you just refer to your notes, you will be able to understand that. So let us just, once I'll show it to you. Even if you don't understand, it's fine. I'll explain once again later on, no problem. Okay. So yeah. Now suppose this is the point, this is the example. Okay, so this is the gain plot that we are having. Okay, we are having the slope also, then we have the frequencies also, and from this we are supposed to guess what the transfer function is. Now, from the Bode plot, initial slope of the gain plot always is determined by the poles at origin or zeros at origin. Okay, up to first corner frequency, initial slope of gain plot always depends on poles at origin or zeros at origin. Now in this case, this is the initial slope. How much is the initial slope that we have? 40 dB per decade. Slope is positive. That means there must be zeros. Okay. If there are poles, then the slope would have been negative. But slope is positive, so there are zeros. And how many zeros are there? One zero would contribute 20 dB per decade. So there must be 2 zeros, because the contribution or actual slope is plus 40 dB per decade, right? So there are 2 zeros in the at the origin. Okay. Now, so that is written also here. 2 zeros at origin. Okay. So this is S square is the term in the numerator. Now, next thing that you are supposed to see, at what point it is changing the slope. In your Bode plot, it changes the slope at corner frequencies, isn't it? So 10 is the corner frequency at which the slope is changing, and 100 is the corner frequency at which it is again changing. So at 10 and at 100, there is some factor. Now we will see which factor it is. See, now this is a straight line. So slope is 0 dB. Straight line means no slope. So 0 dB. So 40 dB, say, if the slope is going to 0, that means what is the change in the slope? Minus 40 dB. If the change in the slope is minus 40 dB at 10, that means at 10, there might be 2 poles. Why 2? I think you have understood. Because there is slope of 40. If it would have been 20, then there would have been only 1 pole. But slope is changing from 40 dB to 0. That means addition of minus 40 dB per decade is there. So at 10, there are 2 poles. Okay. Now at, yeah. So at 2 poles at omega equal to 10, and this is the factor. 1 upon 1 plus s by 10 bracket square. Square because 2 poles are there. Now at 100 also the slope is changing. Now slope is changing by minus 20 dB, because here the slope was 0. From 0 it is going to minus 20 dB. That means at 100 also there is a pole, but there is a single pole because slope is minus 20. So there is 1 pole at omega equal to 100, and this is the factor. Okay. 1 upon 1 plus s by 10. Now, most important thing is the calculation of value of K. Okay. So for calculation of value of K, we need magnitude at omega equal to 1. If you remember, the reference point was omega equal to 1, because at omega equal to 1, the magnitude is shown as per the value of K. If you remember the first sketch of the Bode plot which I had shown, there were two graphs, two magnitude plots. One was a reference plot, and then the second one was uplifted or shifted upwards by 20 dB. So whether it is 0 dB or 20 dB, that can be observed from omega equal to 1, because that's a reference point. So that is why value of K can be calculated from omega equal to 1. Now at omega equal to 1, now suppose if you consider that this point is omega equal to 1, okay, at this point, how will you calculate the value of K? For that, you need some information here. How much is the value here? How much is the value magnitude here? So with the help of that, you will be able to calculate K. That can be shown in another problem probably. But I think this part is clear to you. When gain plot is given to you, first check initial slope. Initial slope will define how many poles or zeros at origin. Then check the frequencies at which slope is changing. Those are corner frequencies. Slope is changing by how much? That will give you whether there is a pole or zero at that particular corner frequency, and then you will be able to guess the factor that you have. Okay, so ultimately, okay, so this complete thing I'll show later on for K, but this part was important from the point of view of sketching the gain plot also. That's why I have shown it. Okay, is that clear now?
Yes, ma'am.
Everyone?
Yes, ma'am.
Okay. So, okay, so that's all for Bode plot. Only the part that remains is this type of problems, that gain plot is given and you are supposed to calculate the transfer function, which might be part of online exam if it happens. Okay. So that part can be covered little bit later on, because one, you should be well conversant before solving these problems. You should be well conversant with actually how the plot is sketched. Okay. Once you are you have practiced it sufficiently, then you can move on to these problems. Okay, so that can be done by you. You can ask me the doubts also. Is that fine?
Yes.
Okay.
Yes.
Now, okay, now people are asking independent questions independently to me on WhatsApp. I'm replying to them. If any one of you have any difficulty regarding Bode plot, you can please send a message to me on WhatsApp, and then I'll clarify your doubt. I'll solve the problem on my own if it requires, and then send it back to you. Okay. Please solve these problems today only, 2 or 3 problems, till you are confident enough that you will be able to solve any problem. And then if required, then 1 or 2 problems of that type which are given in the notes, have a look at it. If you have difficulty in calculation of K, I'll explain that also. And one more thing, I'm taking a gap of 1 day tomorrow. Let me give some time for you to study, and then day after tomorrow I'll be starting with Nyquist plot. Is that fine?
Okay, ma'am.
Yes, ma'am.
Is that fine? Day after tomorrow.
Yes, ma'am.
Okay, so
Yes,
day
ma'am.
after tomorrow at 1:30, 9th April at 1:30, I'll be starting with Nyquist plot. Please get your doubts clarified. I mean, doubts on Bode plot gets should be clarified before that. Okay, I mean later. So I'll reply, no problem. But if your concepts of omega GC, omega PC, GM and PM are clear, then you should be able to understand it in a better way. Okay.
Yes, ma'am.
Yeah, okay. Thank you. You can leave the meeting now. I'll share these notes. Whatever I have done today, I'll share it with Shivam. He will share it with you.
Okay.
Yes, ma'am.
Thank you.
Okay. Thank you.